Hi everyone. Today we're going to be taking an algebraic approach to limits, and there's actually 4 different types that we're going to see. So I'm going to relate this back to the lesson that you just did with graphs. So today we're going to be doing graphs of rational functions, and this right here is a rational function. Rational functions are the ones that have the asymptotes and they kind of look curvy like this. Okay, so those are rational functions. Now, unfortunately, we're not going to have the graph to be able to do this. This is a whole different type of lesson, but we are going to be taking the limits of different parts of something like this without even having to look at the graph. Now, yes, you could graph each and every one of these and then look at the limit from the graph, but it can be annoying to have to graph a function every single time when really you can calculate it with algebra. So there's 3 different scenarios. The first scenario is this one right here, where you can just plug in a. These are 3 different approaches to find the limit. So plug in the constant. So this first scenario is going to work when, going back to that when you have a rational graph, and I'm just asking you to find the limit at a place where the graph is continuous. So like right here, if I were to just say find the limit as x approaches -4, and let's call this f of x, that's the instance where the first approach would work. Now, again, we don't have the graph, so let's do this algebraically. So our very first approach is going to be to actually plug in, or I don't really like this word plug in. Let's change that to substitute in that constant value. So that's always the very first approach you're going to want to take. And this approach is actually called direct substitution. Okay, so if I try direct substitution, if I look at example 1a, zoom in on example 1a, I need to find the limit as x approaches -2 of x squared minus 4x plus 1. So I'm going to substitute in this -2. So let's see if I get a value. -2 squared minus 4 times -2 plus 1. Well, let's evaluate that. -2 squared is 4 plus 8 plus 1. So 4 plus 8 is 12, and 12 plus 1 is 13. And this is actually what the limit is. So when the function is continuous, we can just substitute in this value. I get 13. Another example right here, I have to find the limit as x approaches -1. Let's choose a different color. Of 2x minus 6 over x minus 1. So again, I'm going to try direct substitution. I'm going to substitute a -1 in for each of these x's. So I'll say that that is equal to 2 times -1 minus 6 over -1 minus 1. Let's evaluate that. 2 times -1 is -2, and -2 minus 6 is -8 over -1 minus 1 is -2. And -8 divided by -2 is +4. So I can say the limit as x approaches -1 of 2x minus 6 over x minus 1 equals 4. So this is the first type that you're going to have.